looking at vectors in space, and vectors are denoted very similarly. So I have my vector v, and it's denoted by 3 coordinates, just like that. Okay, the 0 vector, 0, is just 0, 0, 0. I have unit vectors. I is 1, 0, 0. J is 0, 1, 0. And K is 0, 0, 1. So they're each have a magnitude of 1 in the direction of x, y, and z, just like two-dimensional we had x and I, just I and j. So I can also write standard unit vector notation. So I could also write v to be v1 I plus v2 j plus v3 k. Now I have a definition. I want to talk about vectors in space. So I have u is going to be u1, u2, and u3. And v is going to be v1, v2, and v3. Make sure you know that these are u's. And I'm going to have c as a scalar. So c is some scalar. So I know the first one is equality of vectors. And that tells me the vector u equals v if and only if u1 equals v1, u2 equals v2, and u3 equals v3. I have a component form. And if I have v represented by from P to Q, so V is a directed line segment, then my V, which is V1, V2, V3, equals Q1 minus P1, Q2 minus P2, and Q3 minus P3. Remember, direction is important, so since I'm going from P to Q, it's Q minus P. I have a length. It's just my magnitude, so my magnitude of V, and it's the square root of each of the components squared. I have a unit vector, just like before, so I have a unit vector in the direction of V. And that's just going to be 1 over the magnitude of V times V, which equals 1 over the magnitude of V times V1, V2, V3. And but I have V can't be 0, otherwise I can't divide by 0 for magnitude. I can add them by vector addition. And V plus U is the same as V1 plus U1, V2 plus U2, and V3 plus U3. And I have scalar multiplication. So if I multiply a scalar times V, it's just like multiplying each of the components by C as well. And then if I want to know about two vectors being parallel, the only way the two vectors can be parallel is if, so U and V, U is parallel to V if U equals some scalar times V. So C is a scalar.